Homework sheet U9, question 3. In part A, we're asked to express 2 cos 3x minus 3 sin 3x in the form r cos 3x plus alpha, where r and alpha are constants, with r bigger than 0 and alpha between 0 and pi by 2, giving our answers to 3 significant figures. We want to start by using the formula book to expand r cos 3x plus alpha, and this gives us r cos 3x cos alpha minus r sin 3x sin alpha. We can now equate our cos 3x terms from left and right hand side to get r cos alpha equals 2, and equate our sin 3x terms to get r sin alpha equals 3. Both the term here and the term here have a minus in front of them, so I don't need to include that when I create my equation. We can eliminate r by doing the second equation divided by the first to get tan alpha is equal to 3 over 2. And using a calculator, this gives us the value of alpha as 0.983 to 3 significant figures. To find r, we want to substitute these into the identity sine squared alpha plus cos squared alpha equals 1. With a little bit of simplifying, this gives us r equals 2 squared plus 3 squared, which is root 13. Now, I am going to use root 13 throughout the remainder of the question, but we were asked to give this to 3 significant figures, so that's 3.61. Finish off then. 2 cos 3x minus 3 sin 3x is equal to 3.61 cos 3x plus 0.983. In part B, we're asked to differentiate fx equals e to the 2x cos 3x to get to the required expression r e to the 2x cos 3x plus alpha using our previous r and alpha that we found in part A. This is a product rule question, so I've divided up u as e to the 2x and v as cos 3x. When I do my differentiation, this involves the chain rule. Okay, e to the x differentiates to e to the x, so e to the 2x differentiates to 2e to the 2x, and cos x differentiates to minus sine x, so dv dx differentiates to minus 3 sine 3x. When I combine these in the product rule, f dash x is equal to u dv dx plus v du dx, so that's e to the 2x times minus 3 sine 3x plus 2e to the 2x cos 3x. Now if I take out e to the 2x as a common factor and I just rearrange my terms so that I'm not starting with a negative, I get 2 cos 3x minus 3 sine 3x. This is the expression that we had in part A, and so we've been able to rewrite that as e to the 2x lots of root 13 cos 3x plus 0.983, and this is the required format. In part C, we're asked to find the smallest positive value of x for which the curve with equation y equals fx has a turning point. We find our turning points when the gradient is set equal to 0, so I've set my expression for f dash x equal to 0. I need to solve this equation to find x. Now I can divide by root 13, because 0 divided by root 13 is 0. I'd have a bit more trouble dividing by e to the 2x, because I'm not allowed to divide by 0. Fortunately, an exponential curve like e to the power of 2x can never equal 0, it can only ever be positive, so I can divide by this term, and just leave myself with cos 3x plus 0.983 is equal to 0. If I take the inverse cos of 0, I can get that 3x plus 0.983 is equal to pi by 2. And then I need to subtract 0.983 and divide by 3 to get a final answer of x equals 0.196 to 3 significant figures.